Good morning, everybody, and welcome to Math with Mr. W. This morning, we're going to talk about square roots. Now, we're here in seventh grade, and I'm not sure if I even had square roots in seventh grade and simplifying square roots in seventh grade, but apparently they do now. And this is not the easiest thing. It can be understood, but we have to just tell kids over and over again. If we know that 5 squared equals 25, then the square root of 25 equals 5. The square root of 25 equals 5. So if you ask somebody, what's the square root of 25? It's 5. Now, there's going to be something different when you get to an equation because it has positives and negatives, and we're not there yet. But right now, let's just deal with the positive or the principal square root. The principal square root says it's 5. Okay. All right. So have your students put these numbers down. These are the integers. And I just got 1 through 20 here. Just 1 through 20. And we're going to look at the square of a number and then the square root of the number. Okay, so what's the square of 1? Well, it's 1. And what is the square root of 1? It's equal to 1. So, easy peasy. Now, let's go to 2. 2 squared is 4. What is the square root of 2, though? The square root of 2. Do I have a number exactly that I could multiply by itself and make 2? No, I don't. I don't have one. That's because, and that makes this number, and here's the word, irrational. This guy is irrational, and we leave him alone. If we think of this radical sign like we've talked about before, if you've seen it before in the Pythagorean theorem the video that I made, then here we go. The square root of 2 is just the square root of 2. Leave it alone. Don't change it to some kind of approximation you found in your little calculator. Yeah, 1.414. So what? Just leave it as the square root of 2 or root 2. We call that root 2. So what about 3? Well, 3 squared we know is 9. But what's the square root of 3? The square root of 3 is just the square root of 3. That's root 3. That's all it is. Leave it alone. Don't 1.73. I don't care. Unless somebody says change that, leave it alone. It's like pi. Pi is a transcendental number. You just have no repeating or terminating decimals. Just like this. The decimal doesn't repeat, doesn't terminate. It's just an unending decimal. So why just leave it alone? Square root of 3, root 3, leave it alone, okay? We just kind of just have to live with it. All right, now, 4 squared is 16. What's the square root of 4? Now, is there a number that I multiply by itself to make 4? Yes, I do. 2. So, I've got a number. This is a rational number, just like this one up here. But these two here are irrational. There's no way that I can find a number that's exactly that multiplies by itself to make that number. Get close. 2.999999999, but it's not going to be 3. 5 is 25 when I square it. But what is the square root of 5? I don't know. Oh, I approximated as 2.236, but who cares? I memorized that. So what? Doesn't matter. Doesn't matter. 6. The square of 6 is 36. But what's the square root of 6? The square root of 6 is the square root of 6. You can't fix it. You just can't fix it. And 7 is just as bad. 49 is easy because I can square 7 and get 4. What is the square root of 7? Now, here's where something gets important to learn, because we have to understand that the square root of A times the square root of B is the square root of A times B. If we understand that law, then this works. So 8 squared is 64. We know that. But what's the square root of 8? Okay. Well, it doesn't have, it's not that 8 doesn't have a number that perfectly makes 8. But is there a factor of 8 that's a perfect square? So I go back up here and I look. Yeah, 4 goes into 8. So I have 4 times 2. That makes 8. So that means I have the square root of 4 times the square root of 2. So that equals what? 2, the square root of 2. So I get 2 root 2. The square root of 2 stays inside just like it did up here, but the 2 came out because the square root of 4 became the 2. And now we get to 9, we get 81. And what's the square root of 9? Finally, another rational number, 3. So every one of these numbers, the square root of 8, 7, 6, 5, 3, and 2 are all irrational. Now, that might ask the question, class, are there more irrational numbers than there are rational numbers? Whoa. That's kind of a mean subject, huh? Maybe a lot of people don't like math because there's too many irrational numbers. Oh, now we get to the square of 10 is 100, of course. But what's the square root of 10? People think, all right, I got, nope, because there's no factors of 10, 2 times 5. But look at 2 stays inside, 5 stays inside. It can't be fixed. If it works, don't fix it. So you can't fix them, leave it alone. It's the square root of 10. It's a little bit bigger than 3. It's 3 and something. Somewhere between 3 and 4. So, and this is what you want your students to have on a piece of paper. Now, let's go to 11 and 12 here, because we want to go down to 20. So 11, what's 11 squared? It's 121. But what's the square root of 11? I don't know. It's bigger than 3. And it's less than 4. Now, how do I know it's less than 4? Because I know the square root of 16, which is 4 times 4, is my next rational number after 9. Look up here, 1, 4, 9, 16. 16 was my next rational number. Everything in between 9 and 16 are going to be irrational, but they may have factors. They may have things that you can simplify. So now, what about 12? 12 squared, of course, is the old 144. 144. And of course, that's a gross. Have a gross number. Huh? So we got the square root of 12. But are there any factors of 12? Yeah, 4 times 3 makes 12, and 4 is a perfect square. So I end up with 2 root 3. 2 times the square root of 3. 2 root 3 for 12. So the square root of 12 is 2 root 3 when I simplified it. Now, 13 squared, well, I know that's 169. Now, again, these are numbers that your students should know. It takes a while for them to really memorize them, to get them in their heads, but they shouldn't have them on a piece of paper. Now, this is not going to be rational. 14 doesn't have anything to go. That's 196. And 15, 3 times 5, nothing there. It's 225. And here we have what? The square root of 15. And that's also irrational. So, and then 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. So, those are the perfect squares. But now, can I change any of these? 17 I can't fix. 18. Does 18 have a perfect square in it? It has a 9 in it. Because it's 9 times 2. So that becomes 3 root 2. So we've got a 2 root 2. Now we've got a 3 root 2. And if you take this out to 100, and this is a great idea, guys and gals, have your students do these all the way out to the first 100 integers and have them in their folders. Make them keep them. Simplify the first 100 integers. It may be so valuable to them, and once they've learned them, they've used them over and over again, it will become real easy for them. Now, 361, well, that's the square root of 19. Of course, that's a prime number. It has no help. And 20. 20. The square root of 20. Is there a perfect square that exists inside 20 as a multiplier? Of course there is. 4 times 5. So, we get the square root of 4 times the square root of 5. So we end up with 2, the square root of 5. 2 root 5. Now, so what have we done here? We've learned to simplify square roots. We've talked about irrational numbers. And we've learned there's a little bit of a pattern. If we keep going, we're going to find a pattern. What's going to be our next perfect square? Well, we know what's over here. It's 25. So when we finally get to 25, that's going to be 5. And that's going to be rational. But everything else is going to be irrational. But we got to look for numbers that have factors that are perfect squares. 4, 9, 16, 25. Those are the ones that are the easiest to come up with. So I hope this helps out. Use this kind of a chart. Make your students do this as a process. It'll make things work for them. It's like learning their multiplication tables. I hope you have a great year. 7th grade can be tough for a lot of kids. It's teenager time. Stress, stress, stress. Have a great day. I'll see you next time on Math with Mr. W.